Hello everyone, welcome to Card Pro Max. So this session is all about the parameterization of the part, design table, catalog editor, power copy, UDF, and document template. So basically, when you will go with the parameterization, we need have some parameters and formula which is linked with the part. Then there are certain condition. What is the use of this parameterization? Basically, this parameterization, with the help of parameterization, we can easily automate the design to detect the predefined design error and maximize the productivity. So it enable the user automate the product and create generic model in order to increase the productivity. And the thing, second point is like capture corporate engineering knowledge and easily share the know-how among all user, ensure the compliance with corporate standard, guide and assist the user through their tracks, allow early attention to the final design specification presenting to the uh, manufacturing. So basically this tool you will find in every in a part design, assembly design, sketcher, in so mostly all of the module you will get this knowledge wire team. So I will go with the part design. You can see here you will get the knowledge wire. Here you will find the formula, then URL and comment, design table, and here you will get the knowledge inspector, log the parameter or unlock the parameters, and here you will get this evaluate dimension, equivalent dimension. So basically this is used to control, this parameter is used to control the size of the geometry, size say part of the geometry, theoretically without knowledge of the design concept. So basically if you don't have any knowledge and you want to change the size of the part or product, you can directly go to the parameters and change the size according to your need. Then this also can be defined in different levels, like you can control in part level, feature level, or as a product level. So while you will if your designer can create a set of user parameter to control the part only changing with that these parameters value. So the value of those parameters can be linked in the design table. So after creating this parameters value, you can link with the design for more, for different types of configurations. Okay, so let if you have a rectangle length and breadth, so you may create the parameterization of the length and breadth. Okay, so you want, you don't want to come again and create change the dimension of the parameter manually. For that we have design table, so that all the length and breadth value whatever you need on all different configuration you can store in design table. So whatever the configuration you needed, you can directly click on that configuration, automatic the design will change to uh, change for the product or as per your requirement. So before going to the parameterization, you should remember some points, like first you need to check the complexity of the product. Okay, if it is a very complex part, you should take the main dimension, so that the you can just imagine the possible way of evaluation of the part. So then you can notice the variable of the dimension, then evaluate together, eventually select the best way to uh, parameterize the part, then you can parameterize the part. So mostly as I said, uh, what you will get in parameters. So I'm just, I won't waste the time in theory, I will directly go to this parameter. You can see here in this parameter types you will find different types of parameters, like integer, string, boolean, length, angle, time. Mostly all the time in parameters you will get here according to your needed. If you want to create the length parameter, you can create the length for a new parameters, and here you can change the parameters. Okay, then here you, if you want in your multiple value or one value, you can put this one. Okay, multiple value or one value, or you want to delete this parameter also, you can delete. Okay, or you can directly import the parameter, so that it will, I'll show you one of the thing parameters. Okay, let I want to import this parameter. You can see the parameters is in a max y m max d dia 1. You can see I have imported the parameters. You can see parameters has been imported. Okay, similarly you can import, or you can create the parameters for creating the parameters as per your requirement of the value of the part. There are two kinds of parameter. One is intrinsic parameters, another is your user parameters. So intrinsic parameters is like that are generated when creating any geometry of the features. Okay, so intrinsic parameter is nothing but whenever you are creating any parts, at that time if you want to create the parameter, that is your intrinsic parameter is, or you can call this is your part level parameters. Okay, I'm just open one of the I'll just open one of the part. You can see this is the one of the parameters. If you want to do all these parameters, I'll go with this formula and see the, click on the part design, and here you will find the length, sorry, if you will go with the sketch level, you will find the activities radius. These are called the intrinsic parameters, like depth, offset, activities. These are intrinsic parameters, and user parameters is nothing but whenever you are creating like a external diameter in meter, that is 47, that is your user parameters. So this user parameter can be defined in a part level, assembly level, or a feature level. When it will comes in the feature levels, it is called as the intrinsic parameters. Okay, then in the parameters you can go with the single value or a multiple value. You can select direct here the single value or multiple value, or else when you are creating the parameters, if you would have this single value, I'm creating the parameters, this is the single value, but after that I want the multiple value, you can go with the add multiple value for that. So it's your wish, you will go with the single value or multiple value in the very beginning while creating the parameters. Okay, then you here you will find some option, like you want to add some tolerance of the parameters, you can add the tolerance. Then you want the step, how many the parameter will follow with a step. So what is the step, you can let I will give it 2. Okay, so you can see the parameter step is changing with two dimension. Okay, similarly you can go with measure between. Okay, so you can link the parameters with measure betweens, so it automatic it will link with the measure between. When it the dimension of the length will change, automatic the parameters will be changed. Okay, so measure between, I need to update. You can see the parameter value is changed automatically. Okay, you can see the length is linked with this. Again, if I want to change this one some value, and you should have update this local update the measure between, automatic the value in the parameter value is changing to this one. So again you want to edit the parameters, you need to double click on this, or you can go with the formula and select the parameters, then you can change edit the parameter as per your requirement. Okay, this is how we can create and edit the parameters. Okay, so what are the advantages of these parameters? The advantages is to have an immediate access. So you can have the immediate access of the geometry, so that you can easily change the value. Then to centralize the key information. Centralize the key information means you want to see that you can change the dimension of the or paired dimension of this part. So this is easily you can see in the parameter, so that you can no need to go inside the part and create the dimension as for your requirement. Okay, give the dimension and it will automatically reflect in your part. Then to refer easily the same parameter when it is relations with the parameter, you can create generic model and driven only by the user of the and the main advantages is to centralize the information, so that any new user, so now you can see it has centralized the information, and if any user come to work on this, then he can understand that this is the pad length, this is the extreme diameter. Okay, you can see I'm just changing the dimension, so that she can understand that this is the whole dimension where the parameter is stored. Okay, so I have telling this thing, but sometimes the system is not on, means this option is not your setting is not perfectly done. So for that, whenever you will go with working with these parameters and formula, you need to go with this infrastructure, sorry, mechanical design, sorry, part infrastructure, and here it is display. Here in the display you need to select this external reference constraint parameters and relations, so that when it will comes to this parameter, creating the parameters, it will show you the parameters and with its value. Okay, this is how we can create the parameters in a part. Okay, so I have a small example, so I need to go, I will show you this. So what I need to do in this wheel rim. Okay, I want to create one of the parameters here. Okay, I want to create one of the parameters. So as I said, you need to imagine um, the finalized parameters, so that you need to imagine before going to create the parameters, you should imagine the um, possible parameters. Okay, you can see this possible parameters, so that uh, when possible way to evaluate the part, so that you can create the parameters and change the parameters, and the design will be changed. Okay, as I see, there are 6 number of spoke. Okay, there are 5 number of bolt hole. Okay, there must be the length, wheel rim length. Okay, this is the length, we can change this length also. So this is the length. Okay, and done. Okay, I have one of the picture also. So we need to create 5 number of hole. One is number of bolt hole, number of spokes, bolt pattern diameter, and rim size. Okay, rim size will give with the multiple value, and you can see here it is showing in inches. Okay, no problem, we will go with the this only mm. So I will create the parameters. Can go with this formula. Go with this formula. Create a new parameter. Giving the sorry as it is. I'm just deleting this. As the spoke is representing the number, so it is a integer. I'm just creating the integer number of spoke. Number of spokes. Okay, so how many number of spoke I want here? 5 number of spoke. Apply. Okay, then you can see one of the parameters has been defined, created. Then second one, number of bolt hole, and that too also integer. Number of bolt hole. Lay this is 6. Then I want here bolt pattern diameter. Diameter means it is the length. Okay, so I will create a length parameter. Create bolt pattern diameter. Okay, there should be some length. Okay, then next one is your rim size. Okay, let's put something. Click OK. Now you can see we have created the parameters. We have just created the parameters. This is how we can create the parameters. So next one is your formula. Okay, so basically formula is used to give the relations between the parameters and the part. Okay, now you can see if I will change this number of spoke, the number of spoke is not changing. We're just creating the parameters, but we should link this parameter to the part, so that whenever we will change this value, it will reflect in the design. Okay, so we'll go with this formula. There are two ways to create this one. One is double click on this, right click, edit formula, number of spoke, number of spoke. So this is the spoke one. Click, and here you may find the angular number. So this is the parameters integer value. Yes, pattern 2. Yes, this one angular number, it is 5. Click OK. It's not created. Right click, edit formula. Now you can see it is linked. Okay, this is one the way you can directly go with the parameters and link with. But here it is very difficult to go, because anytime you will go to this is one of the way. But for that, whenever you want to edit it, you need to go with that pattern and change this one, so that it will reflect in the parameters. The best way to link the parameters is just go to the formula. Okay, go to the formula, select the parameters, select the specific one, and go with the angular number, add formula with that particular parameters. Click OK, and it's OK. Now you can see the number of spoke. Sorry, I have choose the wrong one. So what I need to do is you just go with the formula, select the pattern, angular number is 6, add formula, add to the parameter, apply, OK. Now you can see number of spoke is 6. I can change to 5 also, it will reflect in the design. Similarly, I will go with the formula, select the number of bolt, angular number, add formula, and go with the bolt number of 4. OK. Now you can see apply. When I will go to change this number of a hole, the number of bolt also changing. Okay, bolt pattern diameter. So this is the bolt is diameter. So I am just going to this formula, go to the hole. What is the diameter? 15 point something, 15 point. Just a second. Bolt pattern now. Okay, we'll go with this bolt pattern diameter equal to 15. Okay, add with bolt pattern 15 point something, apply OK, apply OK. You can see the size is changed. The size is changed. So the next one is rim size. So rim size, it is there already. Rim size. So in the rim, this should be the multiple value. So I will put this one some value, 15, 16, 18. Okay. So rim size equal to rim size equal to, okay, rim size radius equal to, you should have something. So rim size radius, rim size by 2. Okay, so we'll go with this. I need to define this rim size radius. rim size radius, go with this, go to the formula, user parameter, rename. Okay, this rim size radius, it should be add formula. It is mentioned rim size by 2. So rim size we have defined by 2. Yeah, rim size by 2. Click OK. Okay. So I'm just clicking OK. It is not taking because it has some dimension. So I will give this value as 200. Multiple value 200 mm. Yes, it's coming like that, but it should be and bolt pattern radius. It should be next to each. Just define this one geometrical set point 1, and here it is mentioned. Go to the formula, select this point, add formula, this diameter by 2. Apply. Okay. Okay, in this way you can create and link the formula to the part. Hope you got the concept. The proper value I am not putting, and that too it should be working. You should be working inches. This is how we can create the parameters and formula in a part. So we have some example. One of the small example, you may do this one. Now I have another small example for creating the parameters and link with the formulas. Okay, so here I have the model. I have one model and one general parameters of the bolt. Okay, so for that you may create one by one and create the parameters, or you may go with the general parameters directly for creating this creating as for making this bolt part as the parameterized part. So what I need to do is I will go with this formula and import that specific general text file. Okay, this general text file, then it will show you the import result that the parameter will create as the diameter, head width, head height, shaft length, is shank length, chamfer angle, chamfer width, then pitch. So if you notice, whenever it will go with this import of done the import, when you will click, it will show you the exact value, like angle is 45 degrees. So it will took the parameter such angle. Okay, click apply. Now you can see the parameter is created, all the parameters is created. So now next point is we need to link these parameters with this fault part. Okay, so what I need to do is I can go with this formula, the simplest way. Click on the pad. Now you can see the head width length. Okay, the head width length means this is the length 17. Up, add formula and go with this head width length. Click OK, apply. Now you can see diameter. Diameter it is showing 10. Is there any diameter? No. So here you can see diameter somewhat it will be 10. Which diameter? I'll click on this head. Yes, this one. This is showing radius. So diameter is by diameter by 2. Okay. Now it is fixed. Now the length. Now the head height. So I will click on this. Head height is 7. So just to add the formula, this head height, click OK. Then I need to select the shaft length. Shaft length is 40. Add, click on the shaft length. OK. Then shaft activity is true. Then shank length. So shank length is this one. Add formula, shank length. OK. Now chamfer angle. This is the chamfer angle. Chamfer angle. Okay. And this is also the one of the chamfer angle. I also link with the chamfer angle this. Okay, 45 45. Then the next one is chamfer width. Chamfer width, I think, yes, this is the chamfer width. Apply chamfer width. Okay. Now almost it's done. One thing is there, that is your diameters already linked. Depth is already linked. Pitch. Okay, this pitch value, it should be linked with this pitch value. Okay, apply. This diameter should be linked with this diameter. Okay, depth is 20 now. This width link with shank length. Apply. Okay, now it is fully linked with the parameters. Okay, now if I want to change this diameter, automatic the diameter should be changed. Okay, that is what you will do in parameters and formula. So I don't want to do this thing manually. Means I want to change this head size value. I don't want to do this thing in manually. This should be or I want this thing in a different configuration, so that the we can get all the configuration with this value, with a different value. So for that, what you need to do is you need to create a design table. So basically this the purpose of a design table to design the to drive the parameters in a CATIA document from external value. So in design table there would be some external value, so that it will take that value and change the design modules. Okay, the design table provides with a mean to create and manage the component family. These components can be example in mechanical part, just to different in their parameters value. So this is in this you will get a different value for creating this. Okay, so now comes to the design table. In design table, whenever you will click the design table, it will ask to you to create the design table with it will ask to you the name of the design table, and you want to comment something, it you can give the comments. And here two option for getting the parameters in the design tables. One is create a design table from pre-existing file. It may be in your Excel sheet or in a text document, or you can create the design table with current parameters value. Okay, and what are the orientation you need in design table? If you want all the orientation in vertically, you can go with vertically, or if you want to or take the orientation of as horizontally, you can take the horizontally. And the destination, what is the destination of the relation? Destination, the design table destination is relation. You may go with this parameter also, no problem. So you may go with the bolt also, sorry, parameters or relations, anything is okay. So I will go with the parameters destination and click my current parameters. Okay, just going with the current parameters. Here how to filter this, the main important is how to filter this parameters value. So what you need to do is you just filter types. You can go with user filter types, or you can go with, okay, if you have the specific filter you can go with the, or you can go with the renamed parameters. So what are the renamed parameters? I will go with this and rename the parameters. Click OK, and I'm just creating one of the design table outside. Click OK. Now you can see, it is linked with the design table configuration, and you want multiple value. As I said, I have created in um, what is that, in a vertical. Okay, let this is 15, this is something 25, let this is 10, let this is 60, let this is 30, let this is 65, 2.5, 3. Okay, and you can see to reflect to in your configuration, second configuration. So in the knowledge report it will show you the design table synchronization whatever you changed. Click OK. Now you can see this is my first configuration, and you can see whenever you will go with this configuration, Here you will find two configuration. If you will select the second configuration, you can see the design is automatically changed, and there are only one seat available and the configuration is 2. This is how we can create the design table with our existing parameters. Okay, let I will delete. Okay, this is how we can go with our existing parameters. If you have all these parameters in an external file, I'll show you one. Okay, like this bolt, I have diameters, head height, length, real SL, then angle, chamfer, then pitch. So I have already these parameters. I want to link with the other one. So what I need to do is I just okay, this is in text value or a Excel value. So we will see both. Okay, I'll go with design table. Here I will select. I can select here. Create a design table from a pre-existing file. Click OK. My pre-existing file is Volt open and apply. Now you can see it is not coming because the associate value diameter it is denoted as D. So what you need to do is we need to associate this value. Okay. Okay. So diameter as D. Okay. Uh, head width as head width. Hidden parameter. Head height is head height. Shaft length is shaft length, angle, chamfer width, pitch. So this is how we can associate the parameter. Apply. Okay. Now you can see the design table is created here, and I want the second configuration. The second configuration is coming like this. Okay. This is the first configuration. This next one is the second configuration. This is how we can create the parameters formula design table and with our existing design table with our external parameter. Now this is how we import the external parameters and link associate with the part. That file it is in Excel file. The same way, if you want to import the file, I want the destination in parameters and horizontal. This time I will go with horizontal. Okay, click OK. And I don't want the Excel file, I have text file, so I will go with this. Click OK, same name. Okay, now we can see it is not associated again it is not associated. What I need to do is I will go with this. Diameter is diameter. The parameter is not complete with column types or just a second. Okay, I'll go with the design table vertical. Sorry, I want the parameter in parameter as my external file in a vertical way, so I will go with the vertical one. Click. Now we can associate. Okay, so I'll go with the filter, rename parameters or user parameters. User parameters means I have created this one, or rename parameters. The same. Associate, associate. All the thing I have associate. Click OK. Now we can see with this apply. Okay. Okay, this is how we can create the design table, and the advantages is to predefine the possible configuration of the model and the case to easy dimension modification, to select the only realistic configuration of the component, to link the parameters value cannot be expressed in mathematical relationship. So basically, if you go with your direct way or creating the parameters within the design itself, or you can go with the external parameters with the associate value, you can associate with this. This is how we can create and do the design table. Okay, hope you got the concept of parameters, formula and design table. Thank you.